All right, hi you guys. Today you're going to be watching a video about how we solve multi-step equations when you have variables on both sides of the equation. So I want to make sure that you are using your man and taking notes as you watch. Pause this as you need to. Our goal, as always, is obviously to solve for the variable. In this situation, we want to get the variable on one side of the equation and get the constant on the other side of the equation. And so I'm going to show you a couple of different ways that we can do that when we solve these kinds of equations. All right, for starters, our steps, as you see here on the right, begin with collecting the variables together on the same side. That doesn't necessarily have to be your first step, but there's a very good reason why I always start with the variable. Once you get the variables together, what you're going to find is that the last two steps are going to very much resemble what we do in solving a two-step equation. All right, so I want you to write as we go. Like I said, if you need to pause, feel free to pause. We've got an equation, 3x minus 2 is equal to x plus 4. My goal, as I said, is to get the variables together on one side. So I'm going to do that by trying to collect these x's together on the same side. In order to do that, I need to move them. I want you to think back to that scale idea. If I take an x away from one side, my scale is going to be way off balance unless I do the same thing on the other side. So I'm going to take this x away from the right side, and I'm going to take the same 1x away from the left side. And now as I go, I'm going to simplify down. What you see here is that I've got in this first lineup of terms, 3x minus x. Well, I know 3x minus x leaves me a value of 2x. So as I simplify the rest of the equation, I can see I've got 2x minus 2. These x's, look at that, are zero pairs. They cancel out. So those are gone. 2x minus 2 equals 4. This should look like a very familiar equation to you because now, like I said, we're at our two-step equation point. So we're going to take our steps to little by little isolate the variable. Add 2 to both sides. I've got 2x equals 6. Isolate that x by dividing by 2, and look at that, x equals 3. You know me well enough to know that, of course, we're going to check our work, and we're going to check it in the original equation. Yesterday in class, we talked about there being a time and a place for doing it in a simplified form, but that original is simplified. So we're going to check it there. So every time I see an x, I'm going to plug in my value of 3 in its place. So I've got 3 times 3 minus 2 is equal to 3 plus 4. And again, we're just checking to see, is our scale balanced? As I simplify, I've got 9 minus 2 on the left equals 7 on the right. Hopefully at this point you already can see that everything is going to balance out and you end up with 7 equals 7. So very easy to solve if you follow the steps. Gather your variables first on one side, then your constants on the other. Previous slide, I talked about first collecting your variables, but what we know is that it doesn't really matter which term you start with. All right, this is kind of a cool thing. You don't have to do this. Put your pencils down, and I want you to just watch. So, as I said, typically I like to start by collecting the variables first, but what I want you to see is that on this page, there are 4 different highlighted terms. And what you're going to see in a minute is that it doesn't really matter which term you start with because we're always going to end up with the same value for x. Just sit back and watch as I do this. I'm going to start by taking the 4x away from both sides, which leaves me with 2 equals negative 2x plus 6. I'm going to start to isolate that term with the variable. Negative 4 is equal to negative 2x. Divide both sides by negative 2, and look at that, I have a value of x equals 2. Let's test this out and see what happens if I decide to take away the 2 to begin with. So this time I'm going to take 2 away from both sides. that leaves me with 4x equals 2x plus 4. Now I'm going to work on getting those variables next to each other or in the same side. I've got 2x equals 4. Divide both sides by 2, and look at that. I got the same exact answer, x equals 2. Let's try it if I start with the 2x. I'm going to take the 2x away from both sides. I've got 2x plus 2 equals 6. I'm now solving my two-step equation. Take 2 away, and 2x equals 4. And divide both sides by 2 to get x equals, once again, x equals 2. And in the last one, let's see what happens if I start by taking away 6 from both sides. 4x is equal, 4x plus 2 is equal to 2x. I'm going to take 4x away from both sides to gather my variables together. 2 is equal to, what did I do wrong here? Negative 2x. That did not work, you guys. Hold on. Let's go back and fix that. Find my mistake. Oh, yes. Do you see it? You probably saw it before I did. Okay, there we go. 4x minus 4 is equal to 2x. I'm going to take 4x away from both sides, and I've got negative 4 is equal to negative 2x. Divide both sides by negative 2, and look at that, x equals 2. So what's the point of all of this? The point is we talk about it doesn't really matter at all which term you start with. So let's just try a couple more of these. I want you taking notes again. So I want this in your min. 2y minus 2 is equal to 4y plus 2. For this problem, it makes the most sense for me to start with subtracting 2y from both sides. But as we know, I could have added 2 to both sides. I could have subtracted 4y from both sides, or I could have subtracted 2 from both sides. It doesn't really matter. It's all going to work out for us in the check, as you'll see. Now I'm going to take 2 away from both sides, and I've got negative 4 is equal to 2y, and I've got negative 2 equals y. And I'm never just going to stop. I'm never just going to go on to the next problem without really checking and verifying and making sure. So let's check and see. 2 times negative 2 plus negative 2, I'm keep changing, is equal to 4 times negative 2 plus 2. So not doing any math yet, just substituting in my values. I've got negative 4 plus negative 2 is equal to negative 8 plus 2. And hopefully by the time you get to this point of the problem, you can already see that you're going to end up with the same value on the left, negative 6, and the same value on the right, negative 6. So go back if you want to. You can pause the video and you can try doing the same exact problem, this time by starting with the 2 or the 4y or the 2 over here on the right side. You will find that for any of your answers, for every term that you start with, you're going to end up with negative 2 as your answer. All right, let's try a couple more of these. And again, just follow along. You should be putting these in your min. If you need to pause because I'm going too quickly, go ahead and pause. I'm going to start with the 2a, removing that from both sides. I've got 9 plus 3a equals 9. Take 9 away from both sides. 3a equals 0. We're not going to freak out when we see a 0. We know that if I divide 0 by anything, I end up with a value of 0. And that's okay, because we're going to verify it in our check, right? Our check is going to catch a mistake if we made it. So I've got 9 plus 5 times 0 is equal to 2 times 0 plus 9. I know that 5 times 0 is 0, so I've got 9 on the left. 2 times 0 is 0 equals 9. And look at that, it checks. All right, let's do one more of these. We're going to take any of them away. First, I'll start with the 8x and the 8x. And I've got negative 2x plus 3 is equal to negative 21. We're going to subtract 3 from both sides. Negative 2x is equal to negative 24. And we're going to divide both sides to isolate that x. And we're left with x equals 12. And we're going to check it. 6 times 12 plus 3 is equal to 8 times 12 minus 21. I've got 72 plus 3 on the left, and I've got 96 minus 21 on the right, 75 on the left, and look at that, 75 on the right. All right, let's just take a real quick look at these last couple of problems. So sometimes we're going to have not only variables on both sides, but we may need to simplify first. Simplify might mean distributing. Simplify might mean clearing fractions. Simplify might mean combining like terms, all of the things that we learned about earlier this week. So for this problem, before I do anything, I just want to break away those parentheses. So I've got 5n minus 3 is equal to 2n plus 6. Remember, if you want to show that middle step, that 2 times n plus 2 times 3, you may do that. You do not have to, though. We're going to take 2n away from both sides. And look at this. 3n minus 3 equals 6. We've got just a regular two-step equation at this point. So we're going to go through all of our steps for solving that. And we are left with n equals 3. The check for this, I would most likely check it after simplified, just like we talked about yesterday. I'll throw my check over here, and we're going to check 5 times 3 minus 3 is equal to 2 times 3 plus 6. We've got 15. I've got 15 minus 3, there we go, is equal to 6 plus 6, 12 on the left, and 12 on the right. So really use that check to verify if your work is correct or not. If you'd like to try this problem on your own, you can. I'm not going to take the time to go through it right now. I think you guys kind of get the point of this. Only last thing is, you know, just like we looked at some examples of equations that represented angles, this is the same thing. So this is just a little quick geometry lesson. These blue angles here are what we call vertical angles, and they are congruent, meaning that they're equal. So if we were to set up an equation, what we would know is that those two angles, since they're equal, the equation would look like this. 8x minus 3 is equal to 7x plus 2. And again, you guys get the hang of this. We're going to take 7x away from both sides. X minus 3 equals 2. And add 3 to both sides to get x equals 5. And you know, of course, we're going to check it. 8 times 5 minus 3. 7 times 5 plus 2. 40 minus 3. And 35 plus 2. Both give us a value of 37. All right, so that's that. I want to make sure that you have everything in your notes. So go back if you need to. Make sure that you have all of these examples in your notes, and then you may go ahead and start the 2 textbook assignments that are coming up next. All right, bye-bye, guys.